All right, so we talked on Tuesday that we're going to go through the book and kind of mash everything together to give you a better feel for what's going on. We just talked about the debugger, and let's do just a little quick review of it and pick up a couple of things for those of you who didn't take a look at the debugger between last class and today. This is a quick piece of code that I put together last night, and all it does, it reads a file, which we're going to do a little bit later today and all next week, and then it prints out the scores from that file, and it's just an example to show you what we can do with the debugger. So here's the debugger. Oh, and by the way, I set the breakpoint at line 9, so that is the end of the for loop. So we'll see that populate as it runs through. So this is the first iteration, and we've read all of the information down. We're looking at the line out of the program, line 9, and you can see how it's set up the variables. What I want you to look at is the list or the array that we've got set up. Notice we see score right down here. Oops, right down, doesn't do me any good to point to my screen. We see score right down here, but notice it's not loaded in the list yet, or the array, whatever you want to call it in Python. It's not loaded yet because we haven't got to that part of the program. And so this is at the very end. I've changed the breakpoint, or after that's happened, this is the second iteration. So you can see that our score list is already started to get populated, and here's the second value that's going to be loaded into it. And notice also we get all this good information about the package and the name and the loader and so on, and in the future that'll start to make more sense to it. Well, if you let this simple program run to the end and look at it in debugger, you can see our array is filled, we've got our last score in, and we're ready to go on from there and print the information out. Hopefully all of you picked up also that if you're going to start after a breakpoint, you hit this little icon right there. And then you can use the arrows at the top to walk up and down through it. So someone pointed out as we were going around the room, it's probably not effective for 10 lines. Absolutely correct. 30, 40, 50, more than 100, absolutely. It depends on how comfortable you are with the programming as you're going through. Let's go into some detail then and accurately take a look at what we're doing with lists. On these slides, I put a page reference number off of the textbook copy of your book. So it should be close within a page or two depending on which edition of the textbook you have. So when we talk about a list, we're talking about a container for a string sequence of values. And that's very important when we talk about a string sequence of values. We can load numbers into a list, but they are going to be loaded as what? They're going to be loaded as a character string. Python gives us a way to turn those back into numeric values, so we're lucky there. So keep in mind, anything you load into a list is going to be a string sequence. As we saw just in the simple demo with debugger, and as you saw when we did our boot camp, information in this list can be processed. We can do a variety of different things with it. If you look at the reserve words that are available when you put a list in, you're going to see three of the primary ones. Append, which is something that we cannot do when we work with a string. We can actually append a list. We can modify the list where we can go in and change a specific index value, indexed value, to a different value. Again, with the string, we can't do that. We can sort a list, and we can also reverse a list. The reason reverse is in there, and many times people say, it doesn't make any sense. Why would you want to reverse a list? In Python, when we sort a list, we sort it A through Z, 0 through 100. So it's lowest to highest. If I'm looking for the highest scores in the grade, I'll sort the list in Python, and then I'll reverse it to have my highest scores on the top. So that's why we have that option. So we can process the values that we have within our list, and it becomes a very useful tool when we talk about that. Now, there are several different ways that we can put data into the list. Probably one of the most simple is input 1, input 2, input 3, but that's kind of messy. All right, and it requires a lot of code that we don't want to work with. So we're going to look at some different options today and next week on how we can populate these lists. This is page 279, and it talks to you in more detail about a list, and I'll point out a couple of things on this slide. First of all, and we talked about this Tuesday, we use square brackets to create a list. And if we have, like the example on the screen that says more values equal empty square brackets, we've created an empty list, and we can populate it. Or the second option that we have, we can create a list, and when we create a list, we can actually populate it. And that would be the next example where we're looking at values. Values equals, and here we're going to populate that list with the initial values. And then finally, we can take a look at any element, and we refer to them as an element, and we'll look at a little more detail on the next slide. But we can pick out any element in our list, and we can examine it. We can look at it. And in fact, we can even determine how long that list is and calculate the number of elements, and we'll see that a little bit later also. Take a look, if you would, for a second at the list on the right-hand side of the column, and notice the index numbers that are there in pink. And let's look at a little more detail about what's going on here. First of all, each element in a list has an index number. Let's get the proper terms down. We're going to call it a list, and then the values within that list are actually elements. And we refer to the elements that we want to use with the index number in the list. This is kind of a review. We talked about this a little bit in Python Bootcamp, but now we're going to get into it in a little more detail. So element, and we refer to it by an index number. And we access that list, again, to print out the information, to manipulate the information. We're going to use the index number to call that information out. And we'll look at a couple of examples of coding this in just a couple of minutes. All right, we've said that the list can be populated in a variety of ways. If you have a small list, the most common way to populate it is just go ahead and put the values in when you create the variable for it. However, and we'll start on this a little bit later this morning, one of the easier ways to populate a list is actually read data in from a file that's recorded on a memory device. So either a hard drive or a portable drive or a thumb drive, and that then allows you to manipulate that data, to store it and manipulate it. And I can see the questioning look, and you're absolutely correct. Not only can we read it, but then we can write that data back out to the disk. And once we do that, once we learn how to do that, then Python becomes a much more useful tool for a variety of different things that we want to do. Now, if you have Python up, you can go ahead and enter this code if you want to. It's just a couple of simple lines, but we're going to manipulate some of the data as we go through. Very simple. We're looking at values. My values is the list that we're creating, and we just put a series of numbers in there. So I'll give you a second to load the code. But before we add to it, let's do a quick comparison between lists and strings, because each of them are necessary and useful in Python once we understand how we can use them. All right, so we already know a list can hold values of any type. It could be numeric, it could be hex, it could be characters, or a combination of any of those. So very useful in the fact that anything we want to put into a list, we can. Strings, however, we know can only hold a sequence of characters, and it's very difficult to manipulate that string once we get it in. We know that strings are immutable. They can't be changed. Once we create a string in Python, it's there forever, and we can't go in and change a character. Unlike a list, which is mutable, which means we can go in and change any indexed character that we want to change. If we had a list of last names of the class and somebody changed their last name, as long as I know the index number, I can go in and change that last name to whatever the different last name is, or the different first name, or whatever we want to change in the list. So again, the fact that a list is mutable in Python just adds value to what we can do with our list. Okay. Finally, both a string and a list start at an index number of 0. And we can go in and we can count the characters in a string starting with 0. We can even say that's an index of a string, but we really can't manipulate that string again as we could with the list. So this morning, through the first 12 minutes of the presentation, you've heard me mention many times strings are immutable. We can't change them. So that's something important to remember. All right, we've got some common errors that they outline in the textbook as we work with lists that can get us in trouble. So if you know what they are, it's kind of helpful. One of the things is not staying within the index range. And you'll say, oh, wait a minute, why wouldn't that happen? Or how would that happen? If you create a blank list, there are no index ranges. You can go for as far as you want to, and you're absolutely correct. However, periodically what happens is somebody will create a blank list, and then the sequence of reading the data that they want to put into the list gets run before they actually run the list, and the error will come back, index not found, or index out of range. So that happens. The other problem where this happens is if you set up a range where you want to read, let's say, index numbers 250 through 330, and your range, for some reason, the numbers get out of whack. And so your range tries to read an indexed list beyond what the index numbers are. That's another time when it'll happen. So those two, in my experience, have been the most frequent ones that occur. Be creative, and if you generate a index error, feel free to share it with us, and everybody else will learn also. I just told you that. Ignore most likely to occur. I should look at my slides more often. Okay. When there are 10 elements, we have to remember that that 10th element is 9. Again, we're starting at 0 when we count. So the 10th element will be 9. The 11th element will be 10. So that's another thing we need to write down and remember, that when there are 10 elements, the 10th element is going to be number 9. Shouldn't have any problem with that. All right, let's go back to the code that we created. Here it is right here. We're printing. This time, we're going to change line 6 And notice how we modified that. We put in a command called length my values. And so what Python will do for us is determine the length of our list, the index of our list. Go ahead and run that, print out my elements, and then get ready to answer. See if you can anticipate the question. There's 9 numbers. So what's our index range? You anticipated the question. Very good. What's our index range?
0 to 8.
0 to 8. 0 to 8. 9 numbers, we'd have 0 to 8. So if I wanted to use my elements to reference the last number, say our list is a couple hundred thousand index numbers long. If I wanted to print the last index number, I'd take my length minus 1, and that would give me the last number in that list. Okay? Any concerns about that? Do it and ask if you're not sure. It all hinges on the fact that we count the first element in a list as 0. But when Python calculates the length, it tells us how many numbers are in the list. It doesn't tell us the index number. So you subtract 1 and you get the maximum index number, if you will. All right, let's go through and let's modify our program a little bit more. Let's take our values and throw in a for loop. And let's print the information that we have available. But let's go a step farther. There are some more fun things that we can do with lists. We've talked about append, we've talked about sort, we've talked about a reverse, but we can actually slice a list and look at a selection from it. So all we would do is add the bottom line of code here, print. I use some list in this example. We're using square brackets, as you can see, but I give a starting index number, or a starting number and an ending number. So go ahead and try this and see what happens. This is what the result should look like. And what you're seeing a partial printout of is the list that I created. It printed the list out. That's in the for loop that we're using here. And then the print statement, print, in your case, my values square 6:9, should give you 3 values down at the bottom. Lists, really great. We can do a lot with them, but who wants to sit there and fat finger in 2,000 records into a list? Good information, but what do we do now? Well, this is the part of the class where I say the next part of the story is text files, and we're going to jump ahead to page 342 if you're following along in the textbook. There are some unique things that we need to look at text files overall and specifically within Python. And what I'm talking about when I talk text files is for data, we're normally talking about comma delimited files, files that you can generate out of Excel if you want to, or files that are generated out of Notepad. They will always have the extension of .txt, text files, and that's what Python is going to look for. So these are very portable files. I can take a data file created in Excel and read it in Python. I can read it in C#, and hey, believe it or not, I can also read it into an Oracle database file and create a database. So text files are known as being very portable. By the way, should you try to create a text file and Microsoft Word gives you that option, it will not work in many cases because the characters for quotation marks, for spacing and in many cases for tabs, if you would use that to try and set up your text file, are actually read into that text file created in Microsoft Word and several of the other word processing programs. The only two that I've worked with are CorelDRAW, Microsoft Word, and there's one other one. I can't think of whatever the Apple one is. But they actually generate characters you can't see within that text file. So Notepad is a very good program if you want to create a text file. Excel and save the file as a CSV file, comma separated file. Also, there is a program that you can download for free called Notepad++. I think Ken may use this, and some of the other instructors may use it. I use it in a couple of my classes. And not only will it allow you to write code, but it'll actually allow you to generate pure text files. So that's one of the things you want to look at, and if you try and read data in from a text file and it's not working, the way to kind of purify the file is open it up in Notepad and save it under a different name from Notepad, and it should clear up any character problems that you might have. Well, text files can contain numbers. That makes sense. It can contain characters, and it can have a combination, all of those. And when we talk about characters, we're talking about a text file can also handle the @ sign, or it can handle the number sign, or the boom sign, or the and sign. So there are a lot of things that we can put into a text file. Hopefully you're starting to see why text file on one side, list on the Python side, hey, this is looking like it might be a pretty good marriage. First thing we want to do is we want to talk about opening and writing text files. So we'll look at to open a file. And now we're not going to do any code for this. I want to set the stage, and then I have an exercise that we will all do together next Tuesday in class. And I'll have the code for you, and I'll also have a text file set up out on D2L that we'll pull in and we'll start to manipulate and get you going a little bit further in the right direction. So when we open a file, we've got to provide the name of the file, and that's usually our first argument that we're looking at. Second is W. We're going to tell Python whether we're going to write or whether we're going to read a file. That's one of the key things that it needs to know. By the way, if we're just going to read a file line by line, we don't have to use the R command to read it. We can read it in fairly easily. A warning: if the file already exists and you open it, Python will not say, "Are you sure?" It'll say, "Oh, okay, if you say so," and boom, it'll open it up. All right, so be careful. If you're opening a file that's already there and you're going to recreate it, it's going to erase it. And then, if the file doesn't exist, it's going to be created. Pretty simple. Works extremely well. And unless you need to put, this last bullet, unless you need to put the file in a specific location, my advice is to save it in the same folder that your Python code is going to be saved in. Especially as we're starting off, because that then means that your Python code and your file are associated, and you don't have to worry about drive names or directories. The first place Python is going to look to open a file, or the first place it's going to go to create a file, is the directory that the code is listed in. So as we're going forward and we start the little project we're going to do next week, I'd highly recommend you all have a thumb drive. If you can't afford one, FabLab has a couple that I'll give away. I don't have very many left. And with state budgeting, we probably won't have any for a while. But again, the key is if you don't need to put the file that you are creating or you are reading from in a specific directory, include it in the folder where your code is. And that works extremely well. Well, let's look at how this code might be set up. Don't worry about typing this in. You're going to get to do all of this next week as we get started. What I've actually done is defined a module, and the module is called File Names. And if you remember back to our boot camp in late January and early February, we talked a little bit about modules. And so this module, this function that I've created, I can use over and over and over again. In fact, if I can ever remember to pick it up off my desk, I've got a little notebook that I have pieces of code pasted in from Python. And instead of trying to remember it, all right, how am I going to put in file names? I just go to the book, open up to F, and I've got the file name code that I usually like to use. So if we look at that code, very simply, line 5 is the definition. And anytime we want to call this function, we use the variable file name. By the way, 2 parentheses afterwards. Can I do anything with that in line 5? What might I include in there? Arguments. Okay, so remember, I can send any number of arguments I want to up to a function, up to a DEF function that I set up. Now the gotcha, how many can I return?
1.
1. 1 is correct, but what if I return a list? Then how many different objects can I return? As many as are in the list. But returning a list is still returning 1 object. So we'll look at that next week. Now, if you look at line 6, this is just the way we set up. We create an input file name, input, and the question here is enter the file name. We're going to return the file name, and then if you look down at line 11, that's where we're actually creating the file. File right is going to be our file name. We're going to open it. We're opening it with file name, comma, and then on the last slide where we said we indicated a W to write, that's how we would set it up. So what we're going to call it, what we're going to reference it in the script we're writing is write file, and then after to the right side of the equal sign is actually how we establish that file. And written the way it is on the screen right now, it'll create whatever file name I type in the same folder that my Python code, Python script exists. In this case, Chapter 7 lecture. Okay? Any questions on that part? So we've got creating a file down. We're going to do this again on Tuesday. We can write a string to our file if we want to. Of course, we're just starting off with this in many cases, so we might want to write hello world. There are a couple things that we want to remember. You must write a new line character at the start of every line, or you will get one line in your text file that's 1,000,000 characters long. Now, sometimes that's all right, but if you've got multiple writes, the spacing's going to start to get off, and you're going to run 2 words together, and it can create some problems for you. So my advice, every time you write, start with a new line character. That'll save you a lot of heartache. You can write formatted strings. Take a look at page 345 in the textbook over the weekend if you're interested in that. That means that I could write a string with capital letters. I could use the escape codes. What character indicates an escape code? Backslash. All right, and we've already been introduced to \n, which does what? New line. What do you think \t does? Tabs. Right. tabs over. So if we want to set up a formatted string and it's going to be the beginning of a paragraph, we could have backslash and backslash tab. That would start a new line for us and tab over 5 characters. I think that's still the default, but we can set that in our settings in PyCharm if we want to. So we can write a formatted string. That's not too bad. Remember that we need to close the file when we're done writing to it. Now, some people will tell you, you can go ahead and close the file anytime you want to. And in fact, Python will automatically close it for you, so why worry about closing it after you write? The reason for closing it after you write is you never know when something stray is going to come into your file. Accidentally written, a buffer that's out there that dumps to the file because it's open for some reason. So good coding technique dictates we open the file up, we do all of our writes to it, and then we close that file. All right. Now, if we've got to create the file, that's fine. If we're opening it to append to it, that's something different, and we'll see that a little bit later. Well, if we were going to go ahead and code what we were talking about, this would be the code that we would add underneath our opening, and notice how we write out to the file. Write file dot write. We have to tell it if we're going to read or write, and then we just put the text in that we want to write out. And notice how I've got this set up. I put my new line at the end of each line of code, and so that works. You can put it at the beginning also. Whatever you're comfortable with, do. Notice line 20. I've actually put 2 lines of printed out text there, and I've got a /n involved, and then line 21, very simply, I'm closing that code out. One of the key reasons, along with everything else that we talked about, for closing that code is your input actually goes into something similar to a buffer. If the write statement isn't given, that last line of text that you read into your file may not make it. So again, it's important once you're done with writing that you close that file out and think of it as that actually clears the buffer. Let me see if we can get through reading files and then we'll finish up. All right, we're going to open the file up. We've created a file. Let's open it up and let's read from it. All right, the file must exist or you're going to get an exception. Well, that makes sense. Again, be aware of where that file is going to be stored as you open it up. Question, Cody?
Be in the same directory as
No, let me modify what I said. They do not have to be in the same directory. The advantage of having a read or a write file in the same directory is that you don't have to put in the drive and the directory information. So absolutely true. You could put it in any directory you wanted to. Not a problem. And Python will read and write to it just fine. But you have to know where those are. If one thing that you can look at, let's say you write the code and you're going to transport it to somebody else and have them get it ready to be an application. If you have all the support files within that file, it's always going to run when they set it up to deploy it. So the considerations weigh what you're going to do with the file. All right, but again, my recommendation, starting off, put it in the file where your folder is or where your code is, but you're not limited to that. You can put it anywhere you want to. Okay? Okay, I'll throw you out another comment. Usually if I've got to put it in a separate folder and it's not dictated what I'm going to do, I'm going to put that folder in the root directory. That way it makes it a lot easier to put the code in on where I'm going. But that's up to you all and how you want to do it. The object returned has to be saved as a variable. So as we're reading data from a file, we need to save it. We can save it to just an individual variable, or if we save it to a list, we'll save it to a different index each time that we save it, and we'll see how we do that next week. Obviously, we're going to use a file object. We've only got a couple more slides and then get you out of here on time. All right, reading the file. You've got to first open the file. That makes sense to access the data. To read the data very easily, we're going to provide the file name. That's our first argument. The second argument is going to be the read argument, and many times, unless you're using write and read in the same text, you can read a file without putting that R in there. Experiment and see what works for you. And this would be the code to read the file. We've already established the file name with the code that we already looked at, and so this would read the data out of the file. And so now what I would do is look at read file. And so if I wanted to use a for loop, I might have, let's say, a string index 0 read file. Increment my index to 1 read file. And so it'll start to populate my list in that way. And we're going to experiment with all of that live in the classroom. Okay, we'll remind you there are chapter quizzes out there to take. You can take them as many times as you want to take them. I'll set it up so all the remaining quizzes expire the Friday before finals week. And so that gives you plenty of time to work on them, or plenty of time to put them off until the last minute. Whatever you want. Whichever way you want to go is fine with me. Any questions? Have a great weekend. The people that want to work on Project X, please stay in the classroom. See you next Tuesday.